Good morning, guys. We are Chondria, and today we're going to talk about the week 3 water soil retention activity. I'm doing role 1, and I am the technology lady today.
I am Kiani Racklander, and I am doing role 2.
I'm Charne Vaskovitz and doing role 2.
I'm Montana O'Brien, and I'm doing role 3.
And I'm Chelsea Upman. I'm doing role 4.
Awesome. So welcome to the online version of our meeting today. Obviously, due to the times, we're all online and we'll be doing our experiment with you today to discuss what we think. We're going to go through our template that I emailed you previously. Do you all have it in front of you? We're going to be filling that in today and discussing all the different parts. Awesome. So we're just going to briefly mention the experiment.
So today's experiment is what is consisted of soil and sand, and then
That's all right. And so exactly that. So we'll have soil and sand that we'll be going through. We'll be doing an experiment and see how much water is left at the bottom of our glass cups here. We have our equipment that we have today. We just want to talk through and see if you guys think it's the right thing for the classrooms. So what we have is
1 plastic filter funnel.
We have 2 see-through glasses.
1 smaller measuring containers.
We're going to use 60 millilitres of water.
And then some piece of cotton wool in each container or funnel.
Exactly. A scoop of dry sand.
A scoop of dry soil.
And we'll be using a stopwatch to time it for 5 minutes.
And then we'll just do it on the phone.
Do we all think
What do you think this class will be for?
Pardon, say that again?
Have you thought about what year level you want to make this activity for?
We have a brief idea, but we think we might mention at the end of the experiment and see what you guys think. What relates to content descriptors and so on. So after we do the experiment, we'll have a quick discussion about what we think the appropriate year level will be. As on our original task of what the experiment is, we have changed for us as teachers. We use glass containers, but I think for workplace health and safety issues, we should use the plastic ones, which we will discuss further.
For the students.
Yeah, exactly. Do you think within the classroom, with the email I sent you with the experiment that we have here, do you think the procedure and the way it's set out is appropriate for primary age students?
Yeah, as long as they have some assistance and some supervision, it should be okay. But I definitely think maybe older students
I think it's definitely
preferred for this experiment, but we will see.
And I think it's something that needs to be demonstrated before the students do the activity. So they've got a visual idea of what they're going to do before they, rather than just having to read the procedure and be expected to know what to do, have the teacher demonstrate it in front of them, and then they'll have a better idea of, and even if you don't show them results so they can find that themselves, but just show them how to set up the experiment and how to start it.
Awesome. Yeah, we're just writing notes on this so we can expand on it further later.
Well, I think we should see how it goes, and perhaps we can get the students to do it twice. Maybe we can see how variable the results are. It might be interesting for them to put it and compare, make a graph or something that's appropriate for their maths curriculum.
Yeah,
and even just getting the every group's results and seeing how much they differ is probably a good way to see what the average was and overall what was what drained better.
Yeah, that's awesome.
Is that what you guys agree on? A lot of comparison.
Yeah.
Awesome. So, Montana, do you agree with that part there?
Yeah.
Awesome. So we all agree. Now, we're just going to quickly finish up our notes. And if you just read through what the procedure is and stuff, and just see if you want to change anything, and email me back later. And then
Yeah. Do we need to talk about the health and safety of everything?
we will be bringing that up in a second.
Alright.
First, we're just going to discuss
Right. Did you have the Or do you have any idea about the controlled variables and uncontrolled variables that you could do?
I think the amount of water that we pour through could be a controlled variable.
Same with the amount of solid that we have for it to filter through.
And the amount of time.
So we'll just fill on this table here.
And even using like the same filter, making sure that it's the same. If they're not the exact same, that'll change the results of the experiment.
Yeah. What do we have here? Do you want to briefly discuss a couple of those?
So the controlled variable, so the things will keep the same, is the amount of water that is left throughout the filter through the soil, so the 5 minute, after 5 minutes. The measuring equipment will be kept the same filter, and the glass, well, the water glasses, but the students will have plastic. And then the one thing, so the dependent variable, so measure one thing, so the amount of water poured over the soil. And then change one thing, so the independent variable, we had soil type. So does anyone have any other things to add to it?
On the document you've given us, you talk about the cotton wool and only needing a small amount.
Oh, yes. Right now we're filling in the CMS table. We'll put that up after experiment to see if we can change anything through that.
It'll be interesting to see what the size of cotton wool could alter.
Exactly, because it depending on what filter you have as well and how big the hole is and all those other things.
Yeah.
We want to make sure that all the students have the same size and the same brand and everything for each part of the equipment.
Yeah.
So now, just before we get started, we're just going to discuss a few of the health and safety risks that could come from this experiment. So all of us would have read through the procedure and the experiment, so we have an idea. I'm going to fill in the table while we discuss. So what I have first, I've done the first one just to help you guys out, so we have an understanding. I think that water on the floor is a slip hazard. Do we agree with that?
Yeah.
Yeah, definitely.
So the next column in our table, if you read along, the teacher will demonstrate the appropriate use of materials and equipment to avoid the spillage of water as a slip hazard. So like Brielle said before, we will be explaining it in front of the class first, where all the students will watch and see what we're doing. And then the next column, what would the teacher actually say? So when I'm in the classroom, I'm going to say, if you notice any spills, please step away from it and let me know immediately so I can clean it up. So as a teacher, I would like to clean it up and just walk around the class and make sure everyone's doing the appropriate thing. I will have some teacher aides with those students that need some extra assistance as well.
Sure. Yeah.
Can anyone else think of anything else?
Just like the soil, making sure that the kids aren't throwing it in the classroom or putting it in their mouth, depending on what age they are.
Oh, yeah. So the drinking, the don't eat it, don't drink it, don't use it as a weapon.
Yeah. It'd probably be wise to make sure we have eye washer stations, just to make sure, because sand is so annoying.
So protective. Yeah.
Yeah, probably wearing glasses is a good idea.
Yeah, because sand may come in their eye.
Yeah.
You know. Yeah, so what we want to do is explain the safety rules to the kids. Then we want to make sure we reinforce, don't eat it, don't drink it, don't use the weapon. And we want to say, please do not eat the sand or soil or drink the water. We will say that nice and loud and clear so the students understand before the lesson commences.
And we'll probably say that more than once throughout the lesson.
Yeah.
Just to like reinforce it.
Mm-hmm. The equipment do not want to be used as a weapon. So what we will do is ensure all the equipment is intended for its appropriate use, not as a weapon, and we'll reinforce that again. We'll make sure students are in sensible working groups before the lesson starts. So we will have, or the teacher who's in charge of that experiment will have them already in their groups on a little piece of paper so they can separate them before the lesson starts to make sure that everyone is with the appropriate groups. What we want to say is, once again, don't eat it, don't drink it, don't use the weapon. So this won't be all at one point. We'll be saying it throughout the lesson. If you don't use the equipment appropriately, they will be not participating in the activity. Do we agree with that?
Yeah, definitely. Even as a stopwatch, it says use your phone. We could perhaps put it on the whiteboard or some different mean so they don't have the phone near water.
With the whiteboard thing though, because some kids may be a little bit behind, it won't be a fair result. So I could go talk to the PE department or and get a bunch of stopwatches to hand out to each group.
That's awesome. Yeah.
We have some clocks, I believe, in some of the classrooms we can use as well. So we'll just send an email out and see how much like stopwatches or gear we can use to help make it a fair test for the experiment.
Yeah, cool. We could even, when we decide what year level, we can talk about reading the hands of a clock and get them to figure out what 5 minutes is. That would be an extra maths curriculum subject.
Yeah, exactly. And it depends on the year level as well of how they can read it.
Yeah.
So with our experiment here, we have glasses, workplace health and safety, Montana. What do you think could be an alternative for that? Because we have glass.
Yeah, just swapping it out for plastic for the students.
Yeah. So plastic cups in the classroom instead. And we want to use the plastic cups provided. So we'll say to the kids, please use the plastic cups provided for your safety. And we'll just reinforce that so they understand that, especially in the lower primaries, that glass is not safe
and could break.
So maybe even that could be a part of protective gear as well. They could wear gloves or they have allergies of certain things that it could all come together. Because there may be allergies, like some kids may be allergic to some of the soil or the sand, and we just got to find out beforehand and maybe send it out to the parents, say this is the activity we're doing. Because we're using outside environment stuff, we want to make sure that there's no allergies or anything like that.
Yeah, sure.
Yeah. Okay, so that table is completed. Do we have any other points of health and safety that you can think of?
I don't think so. I think we've summed everything up.
Do we need to discuss anything about differentiating the perspectives? So understanding from an Indigenous or religious background, because I know a lot of the students might find it really different working upon their soil from where they're familiar with.
We could pay respect to the land that they got the soil from, for sure.
Or even just discussing them to have them understand that it is different to perhaps where their home is. We could say that our soil might be richer or thicker, more dense.
Yeah, depending on the year level again, for example, the year fours, they do talk about the different soil characteristics and all the soil layers and everything like that. So we can discuss that previously in a before lesson, and then we can draw on it and bring it up within the science lesson we're doing.
Yeah, if that's the case, year 4 would be perfect. But anyway, let's get going. Cool.
Awesome.
All right, so does anyone have any ideas about the research question? We have here, does water drain fastest through sand or soil? Does everyone agree with that?
Yeah.
Yep, that sounds great.
Which retains the most water?
Yeah.
We'll display that on the whiteboard so the students really understand what the research question is.
And can go back to it if they forget.
Yeah, we can compare the difference between retaining and filtering. Talk about how it could absorb or drip.
Yeah, definitely.
And then for the initial hypothesis, we have if we were to change the soil type, then the amount of water left in the bottom of the glass would be different because the sand has a lower water retention than the soil. So does everyone like the sound of that?
Yeah, definitely.
Yep, that sounds good. So you're saying that the soil will retain more water than the sand?
That's what we're predicting, but we will see after the experiment.
We could even send an email home and get parents to do it with their soil in their yard and see if it's different. I mean, see if they're willing.
Yeah, it depends on what parents do for work and stuff to get all the equipment that we need. Is
Could be a cool holiday activity suggestion.
Yeah, or we can make it into more than just one lesson. We can do another one another day. We can draw on it. At the end of the day, it's about them understanding what we're doing. It's not a rush process. We can do another day as well for another lesson.
Yeah.
But that was a good idea, definitely. We can even, at the end of it, say what we did for the lesson, and we can send out some things to the parents, and they can do it at home at their own choice. It won't be marked, or it won't have anything to do with us, but we can help.
Yeah.
Some at-home activities, for sure. So at the moment, we're just going to discuss and write notes with our RHS template here and see if there's any questions you have before we start the experiment. So a lot of the other questions will come later, but if there's anything about what we've discussed so far, or we can just get straight into it. It's up to you.
What are we going to use to record the results?
So I'll be doing a table. I'll just write down the results and then I'll build a table later on.
Yeah.
Okay.
So for our demonstration today, we're just going to do one trial, so it's nice and quick so we all understand what's going on. But within the classroom, Montana, how many trials would you like to do with that for the results?
I think 3 maybe.
Okay.
Yeah. And then they'll be able to compare those 3.
So we'll make sure we have all the equipment and all the stuff ready, the materials to make sure there's enough for 3 trials. Yes.
Any other notes before we start, or anything you'd like to change or keep the same?
Do we want to have a measurement for how much the cotton wool is? Because your document just says very small piece. Like, do we want to say like a centimetre or something, or will we just do it?
That's a good point.
Let's see what
Just some kids do a big pinch and say this is small compared to.
This is the size we have at the moment.
Okay.
We could actually half that and put it into 2 because obviously we'll be supplying the cotton wool to the students, so we can just put it in half.
Yeah.
Could be pre-done, so they don't have to do it.
Because
And they're all the same for each experiment. There's no
we'll
difference.
just get our stuff set up for you. Just 1 second. Just discuss between yourselves or any questions you may have. We'll just go through. We'll get the experiment started.
If the cotton ball is pre-measured, maybe we should pre-measure the water and the soil and sand as well.
Do you think everything ready on the tables, like everything's ready?
Or even just like the correct spoons.
Yeah, because it does say just a small scoop of soil, so that could be interpreted differently. So if we have like just like 1 tablespoon or
with the measuring ones I have here, have the exact amount on there. So this one is 30 milliliters. So let's just check this for 1 second.
Oh, so that's for the water, 30 milliliters. So you're doing 2 scoops?
2 tablespoons. So that is about 30 milliliters.
Okay, cool.
So what we'll do is just get it organized, grab the water. We'll have these displayed around the classroom too if there's any spillage, and to make sure that there's no slip hazards as well, we're going to have a non-slip mat on each of the desks for each group.
perfect.
Just set up. Sorry.
Can you guys see that?
Yeah, that's good.
Right.
Okay, so if you just want to read through the activity, just so I'll get this stuff out. So you can see that all the way. Awesome.
I'll just do this one.
I'm just going to split this in half.
All right, we've set the see-through glasses on the bench and organised the funnels into place. So we've put them like, because they are angled, we've put them to the side.
As you can see here at the bottom of the beaker, all students will have the same one. It's on an angle, so it doesn't get caught at the bottom.
Yeah, so take a small amount of cotton wool that would block the smallest part of the funnel. And then you want to use the smallest amount of cotton you can get. And then, so we will already have this done for the students.
So I'll do 1.
So is that an 1/8? Is that ripped in half and then half again, then half again?
I just ripped it in half. Because it does fit perfectly. I'll show you in a second. I just want to make sure it's accurate, so I pushed it a little bit more.
Yeah.
Can you see that?
Yeah.
Yep.
Awesome.
So just be pushed down a little bit more.
Yeah, we want to push it. We'll explain this to students with the procedure throughout, and we'll have people walking around making sure they do each step
correctly.
Yes.
Yeah. Okay, and now place 2 tablespoons of the soil into the funnel above the cotton wool and then place the funnel on the lip of the glass.
So just 1 scoop is 2 tablespoons here.
Mm.
So it says
Just while you're doing that, it makes me think we should make sure that we talk to the students about measuring a proper scoop and making sure it's not loaded or over full.
With year 4, they'll have an understanding of the measurements, but we should definitely explain about how full they should be for each one. I think it should be exactly to the top, and then maybe we can even get a plastic butter knife and scrape the top of it.
Yeah, that'd be perfect. I might write that down.
we can have that too.
Yeah, we're just writing that in our equipment list so we can add that. Will be perfect.
Yeah, that's a good thing to add to the equipment.
Yeah. Okay, and now we're going to pour 60 milliliters of water into the funnel all at once. So gently without upsetting the soil or sand too much, but we'll just see how it goes.
Okay, so we have 2 types here. We can put it in here, or I actually have an exact measurement of 60 milliliters here, and we'll have each of the students to have one of these. Obviously, we'll need 2 for each group. So,
and then when it starts pouring, we will put the 5 minutes on straight away.
So I'll put 1 in here, just because, as you can see, we don't have 2 of these today, but because I couldn't get enough equipment from the storage. But I will ensure that they're both the same within the classroom. I'm just doing it for you today. And then I'm going to pour it into here first, and then into this one, so it's the exact measurements, and then I'll use this one to the exact same time. Yeah. Okay? Yeah. So obviously it'll be different on the day, but as you can see, spillage already. So a little bit went in there, so I'm going to take it out so it's the exact measurements. So definitely that health and safety risk of the slip hazard is essential. So maybe we should have a couple of these on each desk ready to go. One, and I'll just scoop it out with this one. 2. So can you get your stopwatch ready? So that's 1. Yeah, and then
that one's measured
2. So they're exactly the same.
So I do it straight away when it pours.
So just read out the method, just to finish off the method.
At the end of 5 minutes, move the funnel away and observe how much water is in the glasses. And then if you cannot successfully measure the exact amount of water, pour the water into a smaller measuring container and see exactly how much water there is. And then after everything, dispose the soil and cotton wool in an environmentally friendly manner, and then repeat the process for the sand, and then compare findings and generate a FH relating to the research question. We're just going to relate it back and then discuss it.
Yeah. So before we get started, any questions before we put it in?
Perfect. That sounds great.
I'm just looking at your sand. There's got a bit. Is that bark?
Pardon, say that again.
In your sand funnel, you've got a bit of bark in it.
Yeah, a couple of them have a few little things. So maybe what we could do is ensure, well, there's a lot of different, because it is straight from outside. We can take a few of the things out, or we can filter it beforehand as a teachers. We can go through and shift it through and see if we can get a lot of the stuff out. But it's completely up to you as teachers. What would we like? Would we like to have a bit of those stuff in there, or straight pure sand and soil? What would you like?
It's good to discuss with the students. Just say, okay, there's bark in there, so how could that change the variables? And we can talk about air pockets and pores in the sand. But that's cool.
I think as well, to be a little bit more accurate, like you said, the students, you would use the same measuring containers, and even using a smaller beaker rather than such a large beaker, so it's a little bit more accurate.
Yeah, 100%.
And even the 2 glasses that you've used with the funnel, an easier way for the students would be to have measuring lines on the cups. So then rather than having to transfer the water and potentially spilling it, at the end of experiment, they can actually just read straight off their plastic cup the measurement.
Yeah, we will check the storage room and ensure we have all that stuff, or we'll go out and see if we can get an order of the exact equipment that we need for this experiment.
Perfect.
Perfect. I think we're good. Pour the water in. Let's see.
Okay, so we'll do it here.
And it says kind of slowly, so it doesn't damage it. Ready?
And finish it up now. There we go.
And then straight away put the timer on, so it's counting down. And now we just observe.
I wonder if when it's finished after 5 minutes, we could squeeze out both of them into a different container and see how much water the solid has retained.
As I'm observing right now, the water on the sand is still sitting on the top. The soil has gone straight through. So it's obviously sitting down here somewhere.
Yeah, it's at the bottom.
Yeah, and it will come through.
I think as well, if you had those measured glasses, you could actually like take a recording every minute and see how quickly
Yeah.
it's on the soil. Whereas because it's in a glass with no measuring, you can't actually make readings, accurate readings throughout. You could, make an observation and say that the soil glass has more water down the bottom than the sand, but there'll be no accurate measurements.
Yeah, that's a great idea because it'll give them something to do for 5 minutes.
What
Otherwise,
I'm
we
surprised
need an alternative activity.
the water is actually clear down the bottom of the soil at the moment. I thought that the soil would discolor the water, which is actually quite surprising.
Yeah.
It looks cloudy there, but it's clear down there.
So there's already water down the bottom. Looks like it's gone straight through.
Yeah.
Mm.
Chelsea, do you want to chat a little bit about the CDSU while we're observing the experiment?
Yeah, sure. I was just thinking then it'd be cool if we could get some microscopes and just maybe for the older classes we could have a look at the water before and after and see if there's any additional bits in it.
Yeah.
Even just some magnifying glasses, see if there's any chunks. But that would just be an additional...
Depending on our level of understanding, what year level, and where we're at with the
Yeah, sure.
content.
So my CDSU findings from this experiment that I've just been thinking about is that the sand will absorb very little water because of how big its particles are. It kind of joins together to make one solid, especially when the water comes, all the pores in the sand will close up and make basically little air pockets all the way through so the water won't filter. With the soil, it should be thought that it will have organic matter in it, and from my science findings I know that the organic matter will absorb more because it's natural and it has very small particles, so the water can just drip through really easily. It'll be interesting to see if we could do this experiment with clay instead.
Yeah,
Just to have an alternative perception, just because I know that the soil has a medium-sized density because of all the little bits and chunks in it. It'll have the water filter through, where the clay will be really, really dense and be able to really figure out how much water it will retain. The sand has a very low nutritional content, so we know that the water is not going to feed off any of the sand. It's just going to go straight through or sit at the top. And has any water gone through? I can't really tell. There's a bit of reflection.
We will
in
show
the sand.
you once the 5 minutes are up. We just don't want to disturb what's going on, and then we'll bring it up to the camera for you. Obviously in the classroom with the students, they will be able to see and get their faces in and have a look exactly what's going on. But due to the online meeting today, we can't do that. But
Yeah, no, it'll be interesting to know if there's any water at all through the sand, because it seems very fine sand, and it kind of locks together more as compared to coarser sand, which would be a bit chunkier. So we could definitely talk about with the students the location and erosion level of the sand, whether it's found from. So whether it's bought as play sand, or we found it at the beach or at the ground at school. It'll be interesting for them to figure out the differences. So perhaps for a separate assessment, we could find different types of sand and do it a few times.
Like,
And kind of same experiment, but 3 different types of thickness of sand. As well, I have known from the past that with a funnel, the bigger the surface area, the more absorbent the product is going to be. So depending on the funnel size, the water will drip more or less. So it'll be interesting as well with the cotton, because I know the cotton will change the surface area. To find a bigger or smaller piece of cotton will make it more or less absorbent because of how much it makes a block.
Okay, pause, and we are done. 5 minutes is up. We're going to take it out. Am I please?
Oh.
In here. I'll take it. Thank you. So after speaking with the other teachers, they have mentioned that using these to measure the exact water instead of the students pouring it out and measuring it, or as Brielle said, having it exactly on the glass will help them be able to read it to the exact amount. So that will definitely change in our equipment, but we brought these for today just to get the exact amount for our results, because you're able to pour and getting no
The
drips,
exact, yeah.
the exact amount.
We'll just show you the water. And how, so for the sand, it's it's hard to see online, but
Cloudy.
it's cloudy, and it has
Cloudy.
little bits in it, and there's not much water. And for the soil, there's a lot more water, and it's more clear.
So compared to
Yeah.
the two, you can see the
Definitely
difference.
They look
Yeah.
quite similar.
I know. I thought that the soil would have been very dirty, but
Right.
Yeah, interesting. Okay.
Montana, how do you think you can best display this on like a graph? Like what type of graph do you think you'd use?
I was thinking, after looking also at, because of the year four curriculum and what they've currently been doing in maths, I was thinking of doing a column graph and comparing the two substances, also the amount of water retained and drained, and doing it that way, I think. What do you guys reckon?
Yeah, that sounds
Yeah,
great.
well, if that's not the curriculum, that would be perfect for my maths inclusion.
Yeah.
If we decide that year 4 is the right class, that would be really cool.
Yeah, well, I've mainly focused on column or picture graphs, and I think out of the two, column graphs would be more appropriate.
Yeah.
And
Yeah,
sorry,
we
one second.
have a picture.
The person who's doing the results, we're just going to take it out in 12 milliliters. So if you could just take notes of how many of these each. So you can go first, Charne, of how many of those you take out, and then just go 12 plus 12 or how much it is.
So we're just going to put it in here. So this is 1 syringe, so that's 12.
And sorry, Shay, are you doing the sand?
Yes,
Yeah, I'll
be
just
doing sand, but I'll just do sand first, and then we'll do the soil. So that's 1, and then
So as Brielle said, this is a bit fidgety depending on the year level they're at.
Yeah.
And if we are able to get the equipment that we need with the measurements on the side.
so this is 2 full ones, and then
This
just a
would
little bit.
if it wasn't so much water, but because there's so much water that drained through, I think the most accurate way is definitely to use a lined cup, and it will save the process where students might accidentally drop the glass, spill their water, and then have to restart the experiment.
Yes.
Yeah, we could even get some scales and measure it effectively, because I know that a milliliter can change depending on the liquid inside, whether it has a larger or smaller surface density. So, I mean, we could get some scales from the science room. That would be awesome. We could weigh the glasses and see how much.
Yeah.
We just have to make sure we weighed them before as well to make sure that both glasses were the same weight.
Yeah,
And
definitely.
take that away to make sure that we actually just have the water amount.
But no, I think having some lines would be awesome, because that's a good way to give them something to do for the 5 minutes.
We have to make sure that with the year level of what the measurements are on the side, because this one says 50 as the lowest when they want to do 60. So they got to be able to figure out, or maybe we can draw some lines to make an exact and extra.
Yeah.
Because it only goes 50, 100, 150. So the exact measurements will be hard for those students that have trouble trying to identify whereabouts the other line would be. Yeah.
I think when you can get smaller beakers, that they actually have smaller increments.
Yeah.
We could find a beaker with like 10 increments. That's probably the best way to do it.
Yeah. And then this one goes to 5. So there was 2 lots of 12, and then this one's 5. And that's the sand done.
And I have the soil. So I'll let you finish, Montana, of what the results are in total.
Well, if it was, so it's 26 mils.
Yeah, you're all good to keep going.
Awesome. So I have a full syringe as well, which is 12.
Did we started with 60 mil, didn't we?
We did.
That's how much we poured into each.
Yeah.
It's on the
the sand
email I sent with
26.
the exact measurements. So it was 2 tablespoons, if I was correct.
Yeah.
So another full syringe.
Yeah.
The water was 4 tablespoons. The soil and sand were 2.
That's
So it's half.
So 60 mils initially went in.
Yeah.
Yeah, that's interesting. So I think a separate activity, we should squeeze out the sand and the soil and see how much is retained inside of it. That'd be really interesting to see if it is the remainder from 26.
This is a 10.
Is that 10, sorry?
Yes.
Yeah.
So trying to get the last little bits out. 10. This one is a 2. So that's 12 again. You can add that together.
Yeah.
And every drop counts. That is. That'd be 0.5, I think. 0.5.
Beautiful.
So what was that as a whole?
36.5.
36?
So what do the results show?
So we've got the soil has drained the most water at 36.5 and retained 23.5 mils. And the sand has drained 29 mils and retained 23 mils.
That's surprising.
Based off calculations to get the retained. Obviously, what Chelsea said, if we could do that activity as well to compare, but yeah.
Yeah, so I'm just going to quickly talk about, let me just get up my document. So we want the CMS, we want to talk about list all the things that could be changed. We're just going to write that down in our notes here. So anything that you believe that could be changed for this experiment?
I think.
Well, I still think the different types of sand would be cool. Different substance.
So different sand, different soil. And Brielle, what did you say?
I just think like the measuring equipment is probably something we should change just to make more accurate readings.
I agree.
And the wool size as well, I believe.
Yeah.
And then we're going to talk about list all the things that could be measured. So the amount of water could be measured.
Like Chelsea said, you could, like if you actually drained out, like if you squeezed and compressed the soil and see how much we could actually drain back out, that's probably another way to do it.
Yeah, because this is the CMS we had previously, but now we're just changing it after the experiment to see if it still all fits. So the amount of soil we used in the funnel, the amount of sand we used, all that stuff, now we could get a more accurate reading. The amount of water measured after the activity of how we read it could be changed, and the amount of water as well that we put in, that could be changed or measured through the experiment. So that's just drawing on the CMS table again.
Perfect.
And while we are finishing up our notes, we're just going to discuss the appropriate year level we think for this experiment and the relevant content descriptor for the Australian curriculum. I think this year level will be great for year 4. Do we agree?
Yeah, I think with all of our discussion, that would be awesome. Fits
I
with
know
their
that-
curriculum well for all the other subjects.
And they do earth and space sciences in year 4. And I know that soil is definitely a topic that they learn. So I think that's probably a good way to do it. And like Montana said, she spoke about year 4 doing column graphs. So that's probably a good way to represent it if we stick with year 4.
Yeah. I have copied and pasted a bunch of relevant content descriptors that I found on Australian curriculum before this meeting, and I will send them through to you after. So just to talk about a couple of them, because there are so many that are relevant, which is amazing. So for year 4 within science, the earth and space. So we are, like you said, they're considering the Aboriginal and Torres Strait Islander people through there. We investigate the characteristics of soil, planning, conducting. We are planning and exploring different ways to conduct investigations, connecting these to the type of questions with the guidance of a teacher. We have making and recording measurements using familiar formal units and appropriate abbreviations as such seconds, grams, centimeters, and millimeters, which is relevant to what we just did there with the measuring. Have use a range of methods using including tables, columns, graphs to represent the data. So Montana's doing that at the moment, but I think in year 4 they are able to do the graphs and the measurements and the tables themselves and fill them in with help, obviously.
Yeah.
But with a lot of us, they're at that age that they need to understand a bit more independence of how to do this.
Even just to remind them, like give an example of a column graph on the board. It doesn't have to be anything in relation to what we're doing with our results, but just an example of what yours could look like.
Yes.
And even, like we said before, if you wanted to, once you are finished, go and add your results to the whiteboard, and then we could have a big example of the entire class's results and what the overall result was for everyone, not just as we're talking about doing one trial. You'd have the results from every group in the class.
Yeah. Do you want to say this?
I'm just having a look as well at the year 4 curriculum, and we could talk a little bit about the food chain and how the soil has turned down into the primary producer, because as the soil had chunks and nutrition and stuff in it to make it really organic, we could discuss, that it came from some kind of product in the ground.
Yeah, definitely.
Depending on the location and everything. Yeah.
About depending on where you got it from.
That's actually an Australian curriculum that I was just looking at. So perfect. All right.
Yeah. No, that'll be cool, because I know that they're learning lots about food chains and stuff, so that'll be cool just to link it. I mean, it's not super relevant, but just to link and say, this soil's come from somewhere, it's decomposed and turned into a nutrition, and that's why it will absorb more, because it's got organic stuff in it.
Yeah.
So there's a few more content descriptors that have actually related perfectly to the experiment. Discussing how well predictions match results from an investigation and proposing reasons for findings. So that's exactly what we just did. So they will do that really well, especially throughout and after. And then represent and communicate observations, ideas, findings using formal and informal representation. So that's also what the students can do.
So that would be communicating with the other students with their results that they gathered through the 3 tests that we're going to do, and they're carrying out similar investigations and their experiments to involve the investigation skills. So they compare all the different results. That doesn't have to be done in a lesson. It could be done in the next lesson through the unit. But we can draw on this experiment through a bunch of the different units, through the science investigations, and
it incorporates different subjects too. So there's a lot of maths in this science. They'll be definitely using different subjects throughout it. So they're learning from a wide range of subjects, which is good.
Yeah, that's cool. Even English, we should link a lot of vocabulary talking about the word erosion and even just nutritional content and talking about sand grades, talking about different levels of its thickness. Just get some vocab words in there. That'd be good. We could even link that to their weekly word wall and get them to do the spelling list. That'd be cool.
Yeah, definitely.
Yeah, we should talk to the English department. That'd be cool.
So we have done with our experiment now. We'll discuss further with the other parts of the experiment. But what you have written notes on today, could you please send that through to us? And we'll send through the relevant content descriptors and the filled-in boxes we have and complete this template that we have so we're ready for the upcoming lesson.
Yeah.
So let's talk about the results of what we found.
Yeah. Montana, did you find anything good?
Yeah, okay. So as I said earlier, the soil retained it drained the most water. So it drained 36.5 millilitres out of the 60, where the sand drained 29 millilitres. So our initial hypothesis was correct, saying that the soil will drain the most water. Observations that I found throughout the experiment, liquid came out of the long thin object clear, liquid became cloudy with the darker substance, liquid went straight through dark substance, liquid has become cloudy after going through light substance, more liquid went through the darker substance. Some inferences, water came out of the soil quicker than the sand, leaving the clear colour within the water, however having some particles. Water has retained through sand, turning water cloudy, and the most amount of water was drained through the soil. Did we notice any patterns throughout the experiment that we wanted to make a note of?
I think with ours, because we only did it once, it's hard to see a pattern. But I think if we were to do it 3 times, like we said before, you would probably see a pattern each time.
Mm-hmm.
And would you change something each time, or would you keep everything the same?
I think you would keep everything the same for year 3, but then like Chelsea said, you could do the experiment again with clay, soil, and a soil from a different area, and then try again and see if you have the same results. But I think to notice a pattern in the one, I think you'd probably do all the same.
Yeah, keep it consistent, and then for a new experiment, then we can change some of the.
Yeah.
If they are they going to be in groups when they do the experiment, or are they just going to,
discuss that further? That we'll have groups ready for them on the day. They'll be put in appropriate groups, so they do use equipment appropriately. They are in fair groups. They are helping each other out, and they're communicating and making sure that the behaviour is under control.
Yeah, so mixed ability.
I was just thinking then, if we want to find a pattern of some sort in the initial experiment, we could get one of the members of the group to record its dripping and say how many drips is it in the 5 minutes, or how long is the distance between the drips.
With my observation though, with the soil, it wasn't exactly dripping. It came through very, very fast. The sand was more of a drip, but the soil just went straight through. And because the funnel went through to the water level, you wouldn't be able to see it all come through. The rest would be coming underneath the water. So what we could do that if we get a bigger glass, so it's higher than the water level down the bottom with the funnel, if that makes sense.
Yeah, no, definitely.
It depends what we want to do. With we can discuss quickly which option we like better, or just keep it simple as is for year 4, or we can make it harder through the dripping, get one student. Because in a way, it does make sense to get each student to have an allocated role.
Yeah,
we could do that. We can have different roles allocated. So
like one on the timer, one making sure they have all the data.
One sand, one soil. Maybe groups of 4.
And I think as well, just like we said, if you have the small beaker, you can make a reading every minute. So that will give someone a job that they're seeing how much water's dripped through each minute, and then you can discuss in the results as well. Which could be a pattern that you could talk about is like in the first minute, is it really quick and then it slows down, or is it quicker towards the end of the 5 minutes rather than just looking at the measurement at the end?
Yeah. Recording how much for each minute, that'd be a great idea.
Yeah, and one student will be writing the results down. Maybe we can get 2 students to help with that to make sure it's accurate and fair, and they're just working together well in their groups. If they do not follow the workplace health and safety rules or the risks or any of the classroom rules, they will be out of the science experiment and will not be participating. So that's, once again, we need to reinforce that that's not fair on the rest of the group to have to do that. So we'll have a teacher assistant jump in and to help with that group if the behavior for a particular student is not appropriate for the experiment.
Yeah. Perfect.
Awesome. Well, I think from the final hypothesis, if we're ready for that, guys.
Yes.
Yeah, okay. Well, I mean, absolutely, the great recording is that we have confirmed that the sand will absorb less or retain less than the soil will, or the organic matter. It'll be interesting for us to talk about and discuss with the students if the sand is absorbing or if it's just preventing it from dripping. So we have that whole layer of water at the top. That is definitely a hypothesis that we can discuss with the classroom and kind of confirm or deny that. It will be awesome if we get those extra equipment materials. That will definitely help our experiment.
I'll put an order in with the science department and see if we can get all the equipment we need.
Absolutely.
Just put these out of the storage room through the classroom. So we'll make sure we have everything to make sure the lesson runs smoothly.
And I think as well, an awesome final discussion is that we decided on the recording stuff that Montana has organised. I think that'll be really effective for the students with their extracurricular needs to talk about the ways that we can measure it and the ways that we can observe what's happening, you know. But from the CDSU, I think it's pretty clear for the students. We can discuss the way that it's absorbing and the different textures and thicknesses, and that should be the main discussion and hypothesis of the class. I think just discussing the different absorbent levels compared to surface areas. Yeah. Alrighty. Well, that was great, guys. Thank you.
Thank you.
Thank you.
And
Thanks
I think we
for
decided on year 4.
Yes,
Yeah.
so we will do year 4 for the Australian curriculum. We'll do the content descriptors. I'll send through to you. Any notes and the results that you have, Montana, and the graph you've completed, we will send it through to us, and we'll make sure everything's perfect before we put it in for the lesson and through the unit for science for this year. So we just want to make sure everything's. If you have any other questions, that email it through to us. We'll answer them as soon as we can. And any other questions, anybody? Or
No, that's awesome. If we have all of the materials from the science lab and the, what are they? The stopwatches from the HP area. I think that's
so
awesome.
we're all happy with this experiment. We like how it worked. Just going to change a few little things.
That was
Really well.
really good.
Awesome.
Perfect.
Thank you for coming to our virtual meeting. We are going to just wrap it up now, and Brielle, you can take over with the IT side of it.
Perfect. I will stop recording now. Thanks very much, guys.
Thank you.
You.